Hello, everybody. We got a real easy lesson today on areas of rectangles and parallelograms. This is probably a review. Well, it is a review for my students. So, here we go. First, we're going to talk about the area of a plane figure. So, remember, a plane figure is anything that's flat and two-dimensional. The area is the measure of the region enclosed by that figure. So the measure of the area is found by counting the number of square units that you can arrange to fill the figure completely. So this is a square unit, okay? So it's called a square unit because it's actually a square and it's 1 unit by 1 unit, okay? Which is written as 1 square unit or abbreviated 1 unit squared. Now, even though it says 1 square unit, we do not write it like this, okay? That is wrong. Do not do this. Okay, that means something entirely different than this does. So it's 1 unit squared is the correct way to write that. So here we have a rectangle. It is 9 by 3. Okay, so it's 9 squares this way. It's 3 squares this way. If I was to count these squares, that'd be 27 square units. And so I'm sure that you've just noticed that if I go 3 times 9, that's 27. Okay, so any rectangle can be found by multiplying the base times the height. Okay, so the base of a rectangle, just whichever side is on the bottom, we call the base, and then the height is the side. Sometimes you see it written length times width, it's the same thing. Okay, the area of a rectangle is B times H. So this is a formula you need to know until you die. Okay, area equals BH, where A is the area, B is the length of the base, and H is the height of the rectangle. Very simple. Okay. So let's actually find one more on here. Oops. There we go. If I have a... What's going on here? There we go. If I have a rectangle like so, and the rectangle is, say, 8 centimeters by 4 centimeters, then the area of that, area equals base times height, would be 8 times 4, which would be 32. Whoops, not square units, because we know what the units are. They're centimeters, so this is going to be technical difficulties today. This is going to be centimeters squared. Okay, now we can use that to find the area of other figures on a grid. Okay, so this shape right here, one of the ways that you can do this is to simply count the squares that are in here, and then we have formulas for finding the triangles, but I could divide this thing into a rectangle right here as well, find the area of the rectangle, find the area of the triangles here and down here, and add those together. Okay, or there is also a formula called Pick's formula. Works great on things like these. It says the area is I plus 1/2 B minus 1. Okay, so I stands for interior points. B stands for border points. Okay, so my interior points would be these right here. There's 1, 2, 3, 4, 5, 6, 7, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 1, 2, 3, 4, 5, 36, 37, 38, 39, 40, 41, 42, 43, 44. There are 44 interior points on this, so the area would be 44 plus 1/2. Now we got to count the border points. Okay, so the border points, there's one, none in here, there's another, there's 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. There's none along there. So there's 18 border points. Okay, and then minus 1. So the area of this thing would be 44 plus 9 minus 1, which would be 53 minus 1, which would be 52 square units. Okay, what I got here. Okay, the other way we can do it is we can look at triangles on a grid. So obviously this is 1 square unit right here. That's 1 square unit. Okay, and then we have something that looks like this. That's obviously a half of square unit. Okay, so how do we do things like this? Well, let's see. This triangle, if I made this into a rectangle, this would have an area of 2, right? 1 here and 1 here. That's half of that, so this has an area of 1. This, if I stretch this along here to make a rectangle, this would have an area of 1, 2, 3. So this is half of that, so this is an area of 1.5. Okay. This one here, if I stretch this side out to contain over here, this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this would be half of that. This is going to have an area of 6. Okay. Now, a triangle, the area of a triangle is always 1/2 the area of the base, or I'm sorry, 1/2 the base times the height. Okay, so if you look here, we said this was 1, that'd be half of 1 times 2 would be 1. This would be 1/2 of 1 times 3 would be 1.5. This would be half of 1, 2, 3, 4, 5, 6 by 2. That'd be half of 12, which is 6. Okay, so I can find the area of any triangle using this formula right here. Another super important formula. Okay, so the other way that I could do this then would be to take this figure and divide it like this. Okay. Now this is a rectangle that's 4 by 1, 2, 3, 4, 5, 6, 7, 8. So this has an area of 32 right here. And this has a base of 4 and a height of 4. So this would be half of 4 times 4, which would be 8. This is the same thing here. This is 4 by 1, so this would have an area of 2, and this would be 2. Now if I add these all up, I get 32, 40, 48, 50, 52, which is the same thing that I got up there. Okay? So it doesn't matter how you do that. You can also do some of these weirder shapes different ways. So a lot of times the easiest way to do them is Pick's formula. But another way that you can figure these out is to kind of do the outside of these things. So if I took this and went like this rectangle right here would have an area of 1, 2, 3, 4, 5 by 2, so that'd be an area of 10. And then this triangle right here is 3 by 2, so that's 6. Half of that would be 3. So this right here, if I cut this off, that'd be 3. That leaves me with an area of 7. This is 2 by 1, 2, 3, 4, 5. So this is going to have an area of 5 right here. So if I cut this off, subtract another 5, that leaves me with 2. So this triangle had an area of 2 square units. So you can work the inside of a figure like I did Up here, I did the inside. You can work the outside of the figure like I did right here and find out what's left. Okay. Whatever's easiest for you. You can use Pick's formula. This one right here, this one wouldn't be too bad to cut the outside off. There's some that are just brutally difficult on these that you just want to use Pick's formula. So let's say I took this thing right here and did this. Okay, this is 1, 2, 3, 4, 5 by 3, so that's an area of 15. And then this is 2 by 2, so that's half of that, so that's an area of 2 right here, so we can cut that off. That leaves 13. This is 1, 2, 3 by 1, so this, if I cut this off, that's 1.5. So that leaves 11.5. And then this is 2 by 3, so that's 6. Half of that is 3. So if I cut this off, that's 3. That leaves 8.5 square units for that figure right there. You can do this one on your own. Okay. Find the area of a parallelogram. All right, here's the deal with a parallelogram. You can basically take this, chop this off right here. Now, okay, before we do that, this is called the base. This is called the base right here, from here to here. Okay, the height is not this. This is the slant height. That is not the height. The height actually goes right there. Okay, and then the area, if I take this piece that if I start at this corner and I cut straight down, I cut this piece off and I move it over here, I get a rectangle, and that rectangle has the same area as this parallelogram right here. So the area is still base times height. So the base times height formula works for every rectangle and every parallelogram. Okay, so very simple. So on this problem right here, I can still use the formula, and I should always write these down. Area equals base times height. To find this, it tells me the area this time is 42.1875, and it tells me the base is 5.625. So I just go ahead and put those in the positions, and I'm going to find the height this time. So I'm going to divide both sides by 5.625. This looks like a job for my handy dandy TI-84 Plus C Silver Edition graphing calculator, which apparently the batteries are out, which is strange because I just changed them. So let's get out our backup here, and we can do this. 42.1875 divided by 5.625 comes out to be 7.5. Now my units, this is in square centimeters, this is in centimeters, this is also going to be in centimeters. Remember, it's a length, so it's not going to be square centimeters, even though it's an area formula problem. Okay. Alrighty. So here's a nice little lesson for you to work on. This will be a good warm-up for your brain after Christmas break. Have a great day. See you guys later.